Okay, in this video we're going to do a few C programming basics. So I'm assuming you can program in some language, but maybe not C. These are things that came up in the first lab assignment. Okay, so I have a memorized list here inside of the class directory. So in here I have a README file that this just gives a list of some of the common introductory programming assignments that you should just kind of know how to do with no problem. We'll do a couple off of this list that are related to things that came up with the lab today. So we'll start with checking whether a string is a good password. So I'll call this password.c. And so a couple things to remember in a C program. You always have int main, and you should have int argc *argv. Those are for command line arguments. You won't always use them, but you should put them there. And main has a return type. It's returning an integer, so you should have a return statement. Okay, if we're going to use any of the built-in functions, we have to include them. So pound include stdio.h and stdlib.h have some of the more common ones. All right. And then we're going to use Gcc to compile. And if I run this, so that created a file called a.out that's executable. I can run it with /a.out. It doesn't do anything right now. I can also give an option to Gcc-o, and then whatever I type there, it'll name the program that when it compiles. So there's P. I'll remove the a.out. If I run P, it doesn't do anything. Okay, so in here I want to ask the user for a password. I'll printf type a password. Okay, over on the list that we're keeping over here with core information, somewhere inside of there it says that one of your good programming habits is to do just a little bit of code and then test it. So that's what I'm going to do here. So I'm going to compile this. Okay, yes, so we're going to go ahead and compile the program now and make sure that it does what we think. And there it said type a password, and it's not waiting to type anything because I haven't put that part in. There we have printf. So for reading in a string in C, you have to declare a character array. I'll call it S. So this is a character array. There's room for 100 characters there. And then one way to read in string is scanf. You tell it %s for string, and then s. And I'm going to put actually %99s, and that means don't read more than 99 characters because I only have room for 100, and you always need one extra byte, one extra character in a string for the 0 or null character. So room for 99 characters plus 1 null /0 character. That's the way C strings work, is you have a bunch of characters and eventually there's a 0. Okay, let's go ahead and try this out. Make sure it's going to wait for me to type, so now it's waiting for me to type hello. And that's that. Alright, now if I want to check to see if this is a good password, so check if there is an uppercase and lowercase letter. So let's say we do that. So the way to do this is we're going to have to look at each character in the string. Okay, and with this is a character array, so s bracket 0 would be the first character, s bracket 1 would be the second, and so on. But if I want to look at each one, then I'm going to need a loop. So I'll have to have something like for I equals 0, I is less than length of the string, I plus plus. But then I need to know the length of the string, and there's a function for that, strlen s. Okay, so that's one way to do this. And we'll just check in here if s bracket I, okay, so I want to check to see if it's uppercase or lowercase. There is a function called isUpper. Okay, so if it is uppercase, then I want to remember that. I'll say int has upper equals 0, has lower equals 0. 0 for false is typically used in C. There's no Boolean, there's just integers, and we can use 0 for false and 1 for true. Okay, so if there is an uppercase letter, if this ith character is uppercase, then I'll go ahead and set this has upper equals 1. Now I want to check for lowercase. I could do is lower, s bracket I, that works. Or I could also do if s bracket I is greater than or equal to lowercase a and s bracket I is less or equal to lowercase z. So s bracket I is actually, so it's a character which is really just the ASCII value as well. If we look up the ASCII table, and this is in the core information there, but inside the computer, when you have a lowercase a, it's actually storing the number 97. Okay, and then when you have a lowercase z, it's actually storing the number 122. If I have s bracket I is greater than or equal to a, this is really checking if ASCII code for s bracket I is in between 97 and 122. Okay, so we can think of these as characters that are going to go on the screen. We can also think as the number that's getting stored in the computer. All right, in that case, we would say has lower equals 1. Okay, then at the end, we could check if has lower and has upper. If I just say has lower, I'll do two different ways here. Okay, so has lower, has upper equal 1. It's going to be 1 if I had an uppercase letter somewhere inside of there. Has lower, if I just put it like this, is this expression true or false? It's going to be true if this is not 0. That's the definition in C. So I'll put here true if not 0. All right, and the only way that would happen is if this occurred here. So if that's the case, then I'll say good password. And otherwise, bad password. All right, let's go ahead and check this. See, first we have to compile. There's an error. It says str length is not defined, and that should be string.h. All right, that's complaining about is upper still. Let's take a look. In the manual, so ctype.h is what it's wanting. So there's tests for uppercase, lowercase, hex digit, white space, punctuation, and so on. All right, so we're going to do ctype.h. All right, string length is in string.h, and is upper is in ctype. All right, at least it compiles now, and I'll do hello. That should say good password, and there's an awkward lack of a new line, so I'll put a new line here. That's a good password. That should be a bad password. That should be a bad password. Okay. Go ahead and put this on so we can see the whole program. You might pause now and just take a look and remember what each individual part is doing. Okay, so what you want to do with these programs is you're sort of paying attention as we go, but then when it's all done, you want to look at it, and if there's some little part that you're not understanding, then come and ask during class. If we want to make this so that it will ask again, then we need a loop. So I'll do a do while loop. So do while loop. You have what's going to happen, and then I want to do this while has upper, let's see, not good password. So I'll have something that's called not good password that I'll set to 1 if it's a good password. Sorry. Right, I'll set it to 1 initially. So initially I don't yet have a good password. I ask for the password, I check it, then let them know if good. Alright, and if it is a good password, then I set this to 0, and that should stop the loop. Let's go ahead and try that. It's asking again, and then it stops. Okay, so again, there's the final program. We have printf scanf, a loop to check through the string, and some flags. These are called flag variables, some flags to keep track of conditions inside the loop. Okay, so let's say that's it for that example. We also had declaring a string. So a string in C is a character array. Let's see what other example we're going to do. Okay, just a simple for loop to print a line of stars and to ask the user to type something until they're done. Let's go ahead and call this one, start a new program called done.c, and I want to do just the printf scanf. And something done to quit. Okay, so now I just want to have this condition here check whether they typed done exactly. And the way to check, so in C++, you could have said something like this, but in C, if you do this, what it's going to do, what this expression is going to do is it's going to look at the location where S is stored, the location in memory, an address, and then the location in memory where this constant is stored. They're two different things, so they're stored in different parts of memory. That will always be, these will always be not equal to each other. So in C we have to use a function, and the function is strcmp, and that returns 0 if they're different. Note, strcmp returns 0 if the same, like subtraction. So you can think of the strcmp as doing something like s minus done. Okay, that it's 0 when they're the same. Okay, so we have printf scanf, and we keep doing that as long as the string compare returns non-zero. Okay, so we'll do okay, so what if I type no way? What's going to happen? Pause the video, look at the code. What exactly is going to happen? What exactly will be typed on the screen right now? I'm going to press enter. Okay, so we saw two type somethings. There's one, there's another one, and now it's asking again. And the reason is because scanf reads one word. Okay, so it reads until the next white space. The first scanf, it really reads until no, just no, because there's a space. And then it checks the while condition. And then it goes up and prints and does another scanf, and this is still waiting there, so then that comes in. Alright, if we want to read one line at a time, we have to do something else. Either in scanf or use a different function. Right now I'll just type done to verify that that works. Okay, so that's memorized program number 2. Now we have string compare. Okay, next one I'll do line stars.c. So in here now, I'm going to do just a simple for loop to print stars. Okay, so let's say that I want to do 20 stars. So I'll do I equals 0, I is less than how many, I plus plus, and then I'll printf star. Okay, so that will do 20 times printing the star, and afterwards I'll print a/n. So that just prints the stars. I also wanted to show in here the redirection stuff, less than, greater than. So if I do /l and greater than test.txt, what that does is instead of, when you do printf, instead of going to the screen, it goes to this file. So it didn't print anything to the screen. Now if I go to test.txt, that has the stars. Alright, I can do the same thing with the less than. So let me make, I'll make a text file with some passwords. Hello, hello, what, and then OK now. Okay, so now I'll run my password program, which was P. If I do less than passwords.txt, what it does is anytime there's a scanf, it goes to the file instead of going to the screen. So if I run this, it's just going to go all the way through and show all of them. So type a password, and then there's nothing printed here because I didn't type. It just read this hello. It checked the hello, and that was a bad password. The next scanf goes to capital hello, and it checks it. And so those are all bad. Eventually it gets to this one, which is okay, and it said good password. Okay, so you have greater than, which saves the output into a file. You have less than, that reads the input from a file. And then you have the vertical bar, which sends the output of one to the input of another. I'll give an example. So the file, let's see, so I have my passwords .txt. I'll leave that open. Okay, so that is, maybe I want to see how many times does the word what show up in a password. One way to do that is with the grep command. So I can grep for what. And what that does, if I don't give any other options, is it prints each line that has this in it. So those are those two lines. But if I just wanted a count of how many lines there are, I can pipe that to the word count program. WC is a program that either reads from a file or lets you type, and it just counts how many lines and how many characters. So I do grep what, and then when this bar happens, that means it's not going to print the output to the screen. Instead, it's going to send this to the WC program. There are 2 lines in the results from the grep, 2 words, and 17 characters total. That's the vertical bar. So if we want to run one program and send its output to the input of another, that's the vertical bar. And we have our 3 example programs. We'll take this, let's see what we're doing on time. We'll put this in the next video. Alright, so that'll be it for this one. You want to go back and look at these programs, browse to them in your browser or on the server, and make sure that you understand each individual line, exactly what it's doing. And if you don't, then ask in class.